A car weighs more than a ton. A person cannot lift it by hand, yet a small jack from the trunk can raise one corner of the car high enough to change a tire. The jack is not stronger than the person. It is slower. That is the trade. A jack multiplies force by spreading the work over a longer distance. To lift a heavy object straight upward, the upward force must at least match the object's weight. But pushing something up a gentle slope requires less force because the motion is spread along a longer path. That is the principle of the inclined plane. A screw is basically an inclined plane wrapped around a cylinder. Turn the screw many times and the top of the jack rises only a little. But because your hand travels through a much longer circular distance, the force can be multiplied. This is why a screw jack works. The handle gives another advantage. It acts as a lever. When you push the end of the handle, you create torque around the screw. A longer handle gives a larger turning effect for the same hand force. The screw then converts that rotation into a slow upward lift. The important rule is conservation of energy. Ignoring losses, work in equals work out. Work is force times distance. If your hand applies a moderate force through a long distance, the jack can apply a large force through a short distance. You do not get energy for free. You get force by paying with distance and time. Real jacks also lose energy to friction. The screw threads rub, the joints move. Some energy becomes heat. That is why jacks need strong metal parts and sometimes lubrication. There is also a safety feature hidden in the physics. A screw thread can be self-locking. The slope of the thread is shallow enough that the weight of the car cannot easily force the screw to turn backward. Friction helps prevent sudden collapse. That is why the car stays raised after you stop turning the handle. Hydraulic jacks use a different mechanism, but the same broad idea. Instead of a screw, they use fluid pressure. A small force applied to a small piston creates pressure in the fluid. That pressure acts on a larger piston, producing a larger force. Again, the larger force moves through a shorter distance. The common misconception is that a jack somehow creates force from nothing. It does not. It rearranges the trade between force and distance. Your hand moves far, the car moves a little. That small upward motion is enough. A jack is therefore not a miracle of strength. It is a machine that turns patience into power.